So this question is looking at rusting, and it says, why does the nail in tube A rust, but the other nails will not rust? This tube A, it has water, so it contains water, and it contains air, which will contain oxygen, and therefore they are the two conditions that we need for rusting to happen. So it contains water and oxygen, so it will rust. Tube B, now tube B, you can see there's got a drying agent. What that does is it removes water. So tube B, there is no water present, so it will not rust, because you need both water and oxygen to make it work. And it's probably worth saying there, only oxygen is present. And then tube C, what we've got here is boiled water and a layer of oil. So this one here will have no oxygen. So boiling water removes the oxygen. The oil stops any more oxygen dissolving in the water. So tube C is no oxygen, just water. And that's why it doesn't react. Carrying on, we've got magnesium is more active than iron. This shows how we wrap magnesium around a nail, and it's been left for a few days. State what would happen to the nail. So because the magnesium is there, the magnesium is going to react first, so the nail will be no rusting. So here I can say it would not rust. There'd be no impact to the nail at all. When iron rusts, a brown solid is formed. What happens to the iron as it rusts? So if you remember, rusting, we need the presence of oxygen, and therefore we're adding oxygen to the iron. So we are doing oxidation, so it's being oxidized. Give one reason why metals are electroplated. You can say here that one, it improves the appearance of them, so it makes them look nicer. The other thing you can say is it makes them corrosion resistant. But remember, you need one of those two, not both, to get the marks. Last little question is a 6 marker. It says we've got these metals and it wants us to relate the uses of the metals to the properties of the metals. And we've actually got aluminium is 1, copper is 2, gold is 3, we've got brass in there as another one, and we've also got magnesium, and it wants us to do uses. I'm going to call A, and properties B. Okay, so aluminium, we have got aluminium uses. We've got things like cooking foil, cans, electrical power cables. So the national grid contains aluminium in the cables that carry electricity around the country. What properties does it have that allow it to do this? So it's malleable. Remember, that means bendy. Has a low density. Let's go down because I've written it twice. It has a low density. It does not react, so it's not going to corrode in the weather, and it's a good electrical conductor. Second one in the list was copper. So copper is used for things like water pipes. So your homes will contain copper water pipes, and it's also used for electrical wiring, electrical cables in houses. Why has it got this? Well, one, it's got a low reactivity, not easy to react. It's very malleable, so you can bend and shape it, and it's also a very good electrical conductor. One I've just realised I've missed off here, I'm going to do it here while we're together, is gold. So uses for gold, you have got jewellery is used to make gold. Properties Properties of gold is it is not reactive, so we don't want our jewellery to react. It's malleable, so it can be shaped and designed to make it look attractive. Coming back to the list over here, we've also got, oh, it doesn't want to do it, does it? We've also got copper. We've done copper, sorry, brass. So brass is used for musical instruments. Door handles. Houses will contain door handles made from brass, and the pins in the electrical sockets will also contain brass. Properties it has, so it's very hard wearing. So your door handle will be turned and touched many times a day, and it's hard wearing. They're very strong, and it's a shiny appearance. And the other thing we should include on that list as well is it conducts electricity, hence the job in the pins. Magnesium is used in aircraft construction because it's got a low density. It doesn't corrode. And I'm going to put here stronger than aluminium. Because it's an alloy of aluminium, it is stronger than aluminium and therefore better to use in aeroplanes. Very roughly, we've got this table here. I'm going to draw an arrow on it because my pointer's not working. Shows you how many points are available and how many marks you can get for your answers to that question.